In this tutorial, I'm going to talk to you guys about classes in Python. Classes are extremely important in programming and they're not specific to Python. In fact, a lot of other programming languages do support the notion of classes. We use classes to define new types. For example, so far, you have learned about the basic types in Python like numbers, strings, and booleans. These are the basic or simple types in Python. You also learn about a couple of complex types like lists and dictionaries. While these types are extremely useful, they cannot always be used to model complex concepts. For example, think of the concept of a point or a shopping cart. A shopping cart is not a Boolean. It's not a list. It's not a dictionary. It's a different kind of thing. So we can use classes to define new types to model real concepts. Now, in this tutorial, I'm going to show you how to define a new type called point. And this new type is going to have methods for working with points. For example, back to our main program, let's create a list, numbers, 1, 2, 3. You know that here, when we type dot, we get access to these functions or methods available in list objects. Now, similar to this, we're going to create a new type called point. This point is going to have methods like move, draw, get, distance from another point. These are the operations that we can perform on points. So let me show you how to do this. We start by defining a class using the class keyword. And right after that, we give our class a name. Now look at the naming convention I have used here. I've capitalized the first letter here. This is what we call Pascal naming convention. So the convention we use for naming our classes is different from the convention we use for naming our variables and functions. For variables and functions, we always use lowercase letters and we separate multiple words using an underscore. But when naming classes, we don't use an underscore to separate multiple words. Instead, we capitalize the first letter of every word. So in this case, our class has only a single word. If it had multiple words, let's say email client, look, I've capitalized the first letter of every word. Once again, this is called Pascal naming convention, and it comes from the old Pascal language that you might have heard of. So back to our point class. Here we add a colon, which means we're going to define a block. Now in this block, we can define all the functions or methods that belong to points. For example, we can define a function called move for moving a point. Now note that as soon as we type open parentheses, PyCharm automatically adds self here. This is a special keyword, and we're going to get back to this shortly. So for now, in this method, let's print move on the terminal. Now let's define another method like draw. So define draw. And in this method, let's print draw on the terminal. Now let's remove the indentation. We are done with the definition of our point class. So we need to add 2 line breaks. Okay. So with this class, we defined a new type. With this new type, we can create new objects. So an object is an instance of a class. A class simply defines the blueprint or the template for creating objects, and objects are the actual instances based on that blueprint. So we could have tens or hundreds of points on the screen. These are the objects or the instances. So to create an object, we type out the name of our class and then call it like a function. This creates a new object and then returns it. So we can store that object in a variable. Let's call that point1. There you go. Now when we use the dot operator, look, we have these 2 methods that we defined, draw and move. We also have a bunch of other methods that start with 2 underscores. These are called magic methods. We'll look at them later in the course. So now let's call the draw method of our point object and run our program. So you can see draw is printed on the terminal. Now, apart from methods, these objects can also have attributes, and these attributes are like variables that belong to a particular object. For example, here, after we define point1, we can set point1.x to 10 and point1.y to 20. Now we can easily print out these attributes. Let's print point1.x and run our program one more time. Take a look. So the x coordinate of point1 is 10. Now we can create another object. Let's call that point2. So point2, once again, we type out the name of our class and then call it like a function. Now this object is completely different from the first object. So if we print point2.x, look, we get this attribute error because this point object doesn't have an attribute called x. So each object is a different instance of our point class. Now here we can assign a value to point2.x. Let's set that to 1 and then run our program. So we can see the x coordinate of point2 is 1. So to recap, we use classes to define new types. These types can have methods that we define in the body of the class, and they can also have attributes that we can set anywhere in our programs. You have learned how to create new types using classes. Now there is a tiny problem in this implementation. We can create a point object without an x or y coordinates. Let me show you. So point, we create this object here. And before we set point.x, let's print point.x. Run our program. We get this attribute error that you saw in the last tutorial. So point object has no attribute called x. This is the problem we have here. It is possible to have a point object without an x or y coordinates. And that doesn't really make sense because whenever we talk about a point, we need to know where that point is located. To solve this problem, we use a constructor. A constructor is a function that gets called at the time of creating an object. So here on line 9, when creating this point object, we want to pass values for x and y coordinates, let's say 10 and 20. And with this point object that we get here will have its x and y coordinates initialized. So how do we do this? We need to add a special method in this class called constructor. So on the top, we define a new function. Look at the name of this function, double underscore init double underscore. So init is short for initialize. And this is the function or the method that gets called when we create a new point object. Now press enter. So this automatically adds self in parentheses. We're going to come back to this shortly. Now, right after self, we want to add two extra parameters, x and y. So let's type out x and y. And then in the body of this method, we should read the values passed here and use them to initialize our object. So when we pass 10 and 20, these arguments will be used for x and y parameters. Now to initialize our object, we type out code like this, self.x equals x. And then self.y equals y. What is going on here? This self that you see here is a reference to the current object. So back to line 13, when we create a new point object, self references that object in memory, the same object that we are referencing using this variable. So earlier we typed point.x equals 10. With this code, we set the x attribute of this point object. Now what we have in the constructor is exactly the same. We're using self to reference the current object, and then we set the x attribute to the x argument passed to this function. So using this init method, we can initialize our objects, and we refer to this method as a constructor. This method is used to construct or create an object. Okay, so now let's remove line 14. So we create a point object with these values and then print point.x. Let's run our program. There you go. X is 10. We can also change these values later. So just before printing point.x, we can set point.x to 11 and then run our program. So x is updated. Beautiful. All right, here's an exercise for you. I want you to define a new type called person. These person objects should have a name attribute as well as a talk method. This is a very easy exercise, so you can tackle it in probably a couple of minutes. All right, so first we start with the class keyword. We define this person class. Once again, look at the naming convention I have used here. The first letter of the first word, in this case, the only word, is uppercase. Now, in this class, we define all the methods that we need. Currently, we have only one method, that is the talk method. So define talk. PyCharm automatically adds self. We come back to this shortly. For now, let's just print talk. So this is the body of our person class. We remove the indentation and add 2-line breaks after defining our classes. Now we can create a person object. Let's call that John. We set it to person. We can call john.talk. Let's run the program. So we get this message, beautiful. But our person objects should also have a name attribute. It doesn't make sense to have a person without a name. So that is when we use the constructor function. So on the top, we add a new method. The name of this method is _init _. So we call this method a constructor. Now, in this method, we need to add another parameter that is name. So we simply set self.name to name. Once again, self references the current object. So we're setting the name attribute of the current object to the name argument passed to this method. With this, we can go back to line 9. And when creating a person object, we pass the name. Let's say John Smith. Now let's print john.name and run our program. There you go. So John Smith is printed on the terminal. Beautiful. So this is all you had to do as part of this exercise. But let's make this program a little bit more interesting. Instead of printing this boring message here, let's print, "Hi, I am John Smith." So we can use a formatted string with a message like, "Hi, I am." Now we want to dynamically add the name of this person. How do we do that? Well, look at the parameter of this talk method. As I told you before, every method in our class should have this parameter, self. And this should be the very first parameter of every method, okay? So with this self, we can get reference to the current object. So we can add curly braces and type out self.name. This returns the name attribute of the current person object. With this, we can remove line 10, where we print john.name, and simply call john.talk. Let's run our program. "Hi, I am John Smith." Beautiful. Now we can create another person object. Let's say Bob is a new person called Bob Smith. When we say bob.talk and run our program, we get a different message. "Hi, I'm Bob Smith." So each object is a different instance of our person class. In this tutorial, I'm going to talk to you guys about inheritance in Python. Inheritance is a mechanism for reusing code. And once again, it's not limited to Python. Most languages that support classes also support inheritance. So let me show you how it works. Let's say we have this dog class with a simple walk method. In this method, we're simply printing the walk message on the terminal. Now, let's say in a real program, instead of just one line of code here, we're going to have 10 lines of code. Now, what if in the future we want to define another class, let's say cat, and we want to add this walk method there as well? We'll have to repeat all that code in this new class, walk. This is bad because we have repeated or duplicated our code. In programming, we have a principle called DRY, which is short for don't repeat yourself. And here's the reason. Let's say sometime in the future, we discover a problem in our walk method. If we have repeated or duplicated this method in many other places, then we'll have to come back and fix that problem in every single place we have duplicated this code. So that's why in programming, we should not define something twice. So how can we solve this problem? Well, there are different approaches. One approach, which is easier to understand for beginners, is inheritance. And here's how it works. We define a new class called Mammal and move the walk method right there. Then we'll have the dog and cat classes inherit that method from their parent, just like how humans inherit certain attributes or behaviors from their parents. It's exactly the same. So on the top, we define a new class. Let's call it Mammal. Then we need to move the walk method there. So we select it, cut it using Command and X on Mac or Control X on Windows. And then paste it here. Beautiful. Now we want our dog class to inherit this method from the Mammal class. So right after the class name, we add parentheses and then type out the name of the parent class, in this case, mammal. That's all we had to do. So with this, the dog class will inherit all the methods defined in the mammal class. Now there's a tiny problem here. If you look at line 9, there is a red underline here. The reason this is happening is because Python doesn't like an empty class. So right now, our dog class is empty. It doesn't have anything. We either need to add methods specific to dogs, or just to make Python happy, we can use the pass statement, and that basically means nothing. We're telling Python interpreter, hey, pass this line, don't worry about it. But with this, we don't have an empty class, okay? Now, as I told you before, after each class, you should have 2 line breaks. So right now we only have 1 line break, and that is the reason we have this little warning here. So let's add another blank line, beautiful. So our dog class is inheriting the walk method from the mammal. We need to apply the same change to the cat class. So we'll have cat inherit from mammal, and then we use the pass statement here. With these changes, now we can create either a dog or a cat object. Let's say dog1, we set it to a dog object. And when we type dot, look, we have the walk method that is defined in the mammal class. We can easily call it. Let's run our program. There you go. We see the walk message. So both the dog and cat classes are inheriting all the methods defined in their parent class. Now here we can add methods specific to dogs. For example, we can define a method called bark and then print bark. Now we don't need the pass statement because we already defined one method in our dog class. So now when we type out dog1 dot, look, we have 2 methods. One is the walk method that we inherited and the bark method that we just defined in the dog class. Similarly, we can add a method specific to a cat. For example, we can define a method called be annoying. Yeah, I hate cats. So let's print annoying. Now when we create a cat object, let's remove that, cat1, and type out cat1 dot, we have these 2 methods, walk and be annoying. So these are the basics of inheritance in Python. Now, there's more to this that really goes beyond the scope of this beginner's tutorial. If you're interested to learn more about inheritance and other mechanisms for reusing code, I encourage you to get my complete Python course. In this tutorial, I'm going to talk to you guys about modules in Python. A module in Python is basically a file with some Python code. And we use modules to organize our code into multiple files, just like sections in a supermarket. When you go to a supermarket, there are different sections for fruits, vegetables, cleaning products, and so on. We don't have one section with all the products in the supermarket. We have the same concept in programming. So instead of writing all of our code, instead of writing all the functions and classes in app.py, we want to break up our code into multiple files. We refer to each file as a module. With this, not only is our code better organized and structured, but we'll also have the ability to reuse our code. For example, over here in app.py, I've defined 2 functions for converting weight from pounds to kilograms and vice versa. Now we can take these 2 functions and put them in a separate module called converters. And then we can import that module into any program that needs these converter functions. Let me show you how to do this. So let's open up our project panel and right-click the project, go to new and add a new file. We're going to call this file converters.py. Then we go back to app.py, select all this code, cut it, and then paste it into our new module, converters.py. With this, we have cleaned up our app module. It's not bloated with different functions. So as we write more functions and classes, we put them in their corresponding modules. A module should contain all the related functions and classes, okay? Now, you want to import the converters module into our app module, and that is really easy. On the top, we write import converters without the extension. So we don't add .py. We only type out the name of the file. Let me close the project panel. Now, this converters is an object, so we can use the dot operator to access its members. So currently we have defined these two functions inside of our module, kilogram to pounds and pounds to kilogram. So we can easily call one of these functions. Let's pass 70 kilos, get the result and print it out. Run our program. So that is 155 pounds. Now there's also another syntax for importing modules. Let me show you. So instead of importing the entire module, we can import specific functions from that module. Here's how it works. We type out from, then we add the name of our module. So converters, import. Now here, if you press Control and space, you can see the list of all the functions defined in this module. So here we can grab one of these functions, let's say kilogram to pounds. And with this, we can directly call this function just like a function defined in this file, app.py. Compare what we have on line 4 with what we have on line 6. On line 6, we'll have to prefix this function call with the name of an object, converters. So we have to type converters dot, and then we'll be able to access this function. In contrast, when we import a specific function from our module, then we can easily call that function without prefixing it with the module name. So here's what you need to take away. We use modules to better organize our code. Instead of writing all the code, instead of writing all our functions in one file, we break up our code across multiple files. Each file is called a module, and it should contain all the related functions and classes. Then we can import a module into another module. In this case, we are importing the converters module into our app module. And as you saw, there are two ways to import a module. We can import the entire module, and then we'll get an object with the same name as the module. So we can type converters dot, and then we'll be able to access all the functions and classes defined in this module. The other approach is to import a specific function or class from a module using the from import statement. Now here's your exercise. Earlier in the course, we had an exercise for finding the largest number in a list. So here on the top, we have a list of numbers. Initially, we set max to the first number in this list. Then we loop through this list, get each number. If the current number is greater than max, then we reset max. And finally, when we're done with our loop, we print max on the terminal. Now here's what I want you to do. This code currently has no organization. We don't have any functions. We don't have any modules. We wrote all the code in app.py. And that is okay for small programs, but as your programs grow, you need to properly organize your code into functions, classes, and modules. So as part of this exercise, I want you to write a function, call it find max. This function should take a list and return the largest number in that list. Now, after you do this, go ahead and put this function in a separate module. So extract it from here and put it in a module called utils. So in this module, we're going to have a bunch of utility functions. Okay? Then import the utils module into the current module and call this function. Finally, get the result and print it on the terminal. This is a fantastic exercise to teach you how to properly organize your code. So go ahead and spend a couple of minutes on this exercise. So the first step is to define a function called findMax. So on the top, I'm going to define a function, findMax. This function should take a list of numbers. So we add a parameter called numbers. Now inside of this function, we want to have these few lines. This is the algorithm for finding the largest number in a list. We don't want to bring the first line because this is where we create a list. So somewhere in our program, we're going to create this list and then pass it as an argument to find max function. Okay, so let's go ahead and grab these few lines, cut them, and put them inside of find max function. All right, so we find the largest number in this list. Finally, we need to return it. So return max. So here's our function. Now we need to move this into a separate module. So let's go to the project panel, right-click the project, and add a new file. We can also add a new Python file. It's the same. Let's call that utils. So if you add a new Python file, PyCharm automatically adds .py extension. But if you go to new file, we'll have to explicitly type out .py. So make sure to get the extension right. Now, back to app.py. Let's cut this code and paste it into this new module. Okay, beautiful. Now we go back to app.py and import our new module. We can either import the entire module, so import utils, and then access individual functions. So we can call utils.findMax, or we can explicitly import this function from the utils module. It doesn't really make a difference. So we could type from utils import find max. And then we don't need to prefix this with the name of its object. So we simply call find max. Now we need to call this after we initialize our list. So first we need to define the list of numbers. Then we pass that list as an argument to find max. We get the result, which is max. And finally, we print it on the terminal. Let's go ahead and run our program. So the largest number in this list is 10. Beautiful. Now, one last thing before we finish this tutorial. Here we have this little warning under max. And the tooltip says shadows built-in name max. The reason we see this is because in Python, we actually have a function called max, and it does the exact same job as our find max function. So this is actually built into Python. But I ask you to do it as an exercise because it's a great exercise for beginners. Now, back to the warning. This warning is basically telling us that we are overwriting the built-in max function in Python. So we're changing the meaning of this function, and this is considered a bad practice. Let me show you what I mean. So let's comment out what we have on line 4. By putting a hash sign here, we can also use a shortcut, command and slash on Mac, or control and slash on Windows. So now this line is commented out. Look at the color of max here. It's purple. It's the same color as print. And this is the color used to identify the built-in functions. So now we can call this function and give it our list of numbers, run our program, we get the exact same result. However, if we bring this line back, once again, we can use the same shortcut, that is command and slash on Mac or control slash on Windows. Now we are redefining max. So up to this line, max used to be a function, but after line 4 is executed, max is set to an integer. That is the largest number in this list. So we'll no longer be able to call it on line 5. Let's run our program and see what happens. So there you go. We get this type error. Int object is not callable because max is now an integer. It's not a function, so we cannot call it. So to solve this problem, we can rename this variable to something else. So right click here, go to refactor and rename this to maximum. So you can see the warning is gone. Also, we have the same warning in our utils module. So here we're redefining max. And as I told you before, this is a bad practice. We're changing the meaning of built-in functions in Python. So let's rename this as well. I'm going to use the shortcut that is Shift and F6. There you go. And here we can change this to maximum. Enter.